Satu, dua, tiga.
Alright, Assalamualaikum and a good day. So we are from group 1A and today we are going to do a record of our presentation which is regarding lab 11, measure displacement and acceleration of force vibration. So before I continue, I would like to introduce my team members. They are Variable, Muhammad Hidayat, Adam, Nesan, and lastly me, Muhammad Irfan. So next. Okay, first and foremost, let us read about the objective of this experiment. The objective is to measure the displacement and acceleration of a simply supported beam subjected to a forced vibration. Next.
Okay. For the introduction of the lab is harmonic excitation refer to a sinusoidal external force of a certain frequency applied to a system. Okay, harmonic excitation also can be caused by a variety of factors such as machinery rotational unbalance, induced reciprocating force, or even the machine's own motion. Okay, with harmonic excitation at specific frequency, the wave passing through it undergo the boundary reflection that shows in a standing wave form known as a vibration. It is necessary for us to understand that the harmonic response as how the behavior of a machine responds to the others. Okay, next.
Okay, for the part of theoretical background, okay, to demonstrate the resonance of the vibration should be tuned according to the natural frequency of the beam. So as you can see, we can calculate the natural frequency according to the formula given. Okay, but then for the K, which is known as the stiffness, and M is known as the mass of the beam. So the K, which is the stiffness, can be identified using the formula given also. So as we know, okay, E is the beam's Young modulus, I is the inertia of the area, and L is the effective length. Okay, the load on the beam is in a halfway, which is heavier than the beam's weight, so the weight of the beam is ignored. Therefore, the driving frequency of the applied force, the damping levels, and the device mass all influence the beam's vibration. So all these factors can be changed to examine the beam's harmonic response in more depth. Next slide. Okay, the linear variable diffraction transformer, which is known as LVDT, okay, monitors the displacement or velocity of the beam by contacting it during vibration and translating the information into electrical signals. So the accelerometer detects vibration of the beam and also measures the acceleration. That's all.
Okay, for the apparatus that were used in the experiment, we are such as aluminum frame, accelerometer, LVDT, which is linear voltage differential transformer, speed controller, beam supported, which is end-to-end, laptop with the NI LabVIEW software, and last but not least is the motor. As you can see by the experimental setup, with the aluminum frame hold together the beam at the end, and the LVDT, which is used for the to test the motor speed, and the accelerometer will detect it and is connected to the laptop with the software to run the simulation. Next.
Okay, so for the procedure part, there's actually total 8 steps to carry out this experiment. Okay, first, the apparatus must be set up according to the figure shown just now. Okay, next, the accelerometer and the LVDT must be attached appropriately so that the sensor can be touching the beam. So the computer also must be set up in a proper place and it must be appropriate. Next, the out of balance motor connected to the center of the beam and the speed of the motor set, whereas the step 4 will be the data recorder and the motor should be turned on. Step 5, where the recorder was stopped once oscillation reaches steady state. And then we must repeat the step 1 to step 6 until for at least 3 different values of the motor speed. So the data recorder was also switched off once the data had turned into its equilibrium state. So the last step will be step 7 and step 8 must be repeated for different values of loaded mass. That's all.
Okay, for my part, I'm going to explain about the result that we obtained. So we choose 3 types of speed of accelerator, which is 208 RPM, 358 RPM, and the last one 407 RPM. So the value of the value that we obtain is amplitude and excitation frequency. So we'll list out all the obtained value for the 208. For the speed of 208 RPM and 350 and for 407. Next slide. So these are the graph for the accelerator and displacement and for the frequency for speed of 208 RPM. And next slide. Next slide. Is one for the 350 RPM. As we can see, this is the graph that we obtained from the experiment that we did in the lab. And then next slide. So this is the result for 407 RPM. That's all.
All right, thank you, Nathan. So I will proceed with the discussion part. So for the discussion part, this experiment is conducted by using SVI machine called STM1016 test equipment, and there is some unbalanced exciter that is known as the machinery rotating unbalance that will rotate with the various speed, and it causing the major change in oscillation occurs in the simply supported bin. So in this experiment also there is the use of a LVDT sensor, which is an electromechanical sensor that convert the mechanical motion or vibration specifically rectilinear motion into the variable electrical current, voltage or electric signal, and the reverse. So according to figure 5.1, 5.2, and 5.3 has visualized the acceleration and displacement by unbalanced exciter with three different speed of 208 RPM, 358 RPM, and 407 RPM. So basically, this experiment is consists two effect of speed on the harmonic response of the system, which is the first one is time domain, which the speed on the motor is raised from this three speed, and the acceleration also the acceleration and displacement will increase. So next. For the frequency domain also, we can see that the speed of motor increased from 208 RPM, 350 RPM, and until 407 RPM. The acceleration and the displacement of excitance frequency also will be increased. So there is several factors that influence the system to exhibit the different response, especially for three different motor speed. So the first factor is driving frequency of applied excitation, which is cause some change or distortion in the wavelength. And the second one is the natural frequency, which is the force of the system to oscillate in absence of any driving or damping force. So basically, this variable is important since it can determine the characteristic of the system response, especially as the speed of motor was adjusted into three different values of speed. So I think that's all for my part. Thank you.
All right. So finally, we have come to the conclusion part. We have two points of conclusion. Number one, the displacement and the acceleration from the experiment done is known, tabulated, and have been analyzed. And number two, the students, us, will have a deeper understanding about the force of vibration. So that is all for our presentation video. Thank you.